Hello and welcome back. This is the lecture slideshow for week 10. These slides will cover the 10th week of the course. For this set, read Handout 4 and Okasha Chapter 4. Explore also the links to additional content within the Canvas module, Module 4, especially these. Here is this week's main question. Does science actually explain and describe reality? What does positivism offer people seeking knowledge, that is, justified true beliefs? Recall that positivism gave us the idea that if you understand the meaning of a sentence, that is, the specific proposition P it expresses, then you should know what observations would support it and what observations would show that it is false. So, two guiding principles may be derived from positivist thinking. If you know P, then you can conceivably show that P is false. If you can't say how P could be false, then you can't know P. Review also this. What is a theory? Theories aim to do three things. They describe reality, they explain phenomena, appearances, what we observe, and they justify beliefs or claims about the world. Theories aren't facts, they're not opinions, they're not laws. They contain all of these, but each of these must be accompanied by justifications. Scientists are realists, but what does this mean? Here's a question that people divide over. Does the physical world exist outside of human thought and perception? If your answer is yes, then you are some kind of realist. If your answer is no, then you are some kind of anti-realist or instrumentalist or idealist. People who think science provides a more or less accurate description of the world, including what we cannot observe directly, are scientific realists. People who think science provides a more or less accurate description of only that part of the world we may observe are scientific anti-realists. Realists and anti-realists mostly do not disagree about the accuracy and usefulness of science in describing and explaining observable phenomena. What divides them is what we can make of what we cannot observe directly yet. Do we have knowledge of what we can't observe? So let's contrast observables with unobservables. Observables are things like planets, organisms, tables, chairs, viruses, molecules, physical elements, current events. Scientific realists don't think that a distinction between alleged observables and unobservables is clear, but anti-realists do. What are unobservables? Well, things like laws and forces of nature, causal relations, beliefs, species, atoms, electrons, elementary particles and their various properties, remote past or future events. Scientific anti-realists say that we detect electrons, for example, in a cloud chamber, but that we do not observe them. Our detectors are tools or instruments for useful predictions, but that is all. Is this a distinction without a difference? Anti-realists think it does not matter that we can't always draw a sharp line between observables and unobservables. The point is that we have limits on what we can conclude given our instruments and observations that should therefore limit what we think we can know about the physical world. Fair enough. What, if anything, are we seeing? Here is an image from a cloud chamber. Physicists think such images show that subatomic entities are or behave like particles. So, are we actually observing subatomic particles or not? So let's compare realists and anti-realists about scientific theories. What do scientific theories do? For realists, scientific theories tell us how the world actually is, in both its observable and unobservable aspects. Karl Popper was a realist. Here's an anti-realist theory, constructive empiricism. Scientific theories tell us how the world is in its observable aspects and how the world could be in its unobservable aspects. This is now the most prominent form of anti-realism based on the ideas of Bas van Fraassen. See pages 67 to 70 in the Okasha text, chapter 4. Most scientists, modern scientists, are realists. Science aims to give us, in its theories, a literally true story of what the world is like, and acceptance of a theory involves the belief that what it asserts is true of the world. Here's Karl Popper. You'll recall he thinks theories can be falsified, but not verified. I see our scientific theories as human inventions, nets designed by us to catch the world. To be sure, these differ from the inventions of the poets, and even from the inventions of the technicians. Theories are not only instruments. What we aim at is truth. We test our theories in the hope of eliminating those which are not true. In this way, we may succeed in improving our theories, even as instruments, in making nets which are better and better adapted to catch our fish, the real world. Yet, they will never be perfect instruments for this purpose. They are rational nets of our own making and should not be mistaken for a complete representation of the real world in all its aspects, not even if they appear to yield excellent approximations to reality. As you are no doubt aware, whether global warming is real is important to all of us, including those of us who are realists and anti-realists. I remind you what scientific consensus about this issue looks like. There's some noise, but on average, authoritative agencies, reputable, credible sources of information on this situation agree. In the rest of this lecture, I'm going to focus my examples in particular on biology. So here's a question. Are birds actually dinosaurs? This is what scientific consensus looks like. It turns out that not only are birds apparently descended from dinosaurs, they actually are. Only realism makes the most sense out of all data, observed facts, and predictions, and yet anti-realists are right that as descriptions in language sharpen, what we think we know changes. For instance, now, as a mature, older man, there are more species of dinosaurs in existence, described in paleontology, than there were when I was a kid. Now, how can that be? What's changed is the methods and the findings about ancient reptiles that has caused us to redescribe fossil data, comparative anatomy, DNA, in such a way that now there are more described forms of dinosaurs than there were by scientists in the past. Here, for instance, is a baby dinosaur. This is a great blue heron. Did you know they look like this? Do you still doubt they are dinosaurs? So let me summarize scientific realism at the outset. I'll use SR as the acronym to stand for scientific realism. It's the mainstream view that scientific theories are best understood as more or less accurate descriptions of real phenomena. Framing hypotheses and testing predictions via observation and experiment is a reliable procedure, not a perfect procedure, not an infallible procedure. It's a reliable procedure for obtaining and improving knowledge, justified true belief of phenomena. Scientific theories with predictive success actually explain phenomena. That is, those that make accurate predictions do so, succeed in doing so, because what they say is true. The world described by scientific theories is largely independent of our thinking, language, and theorizing. So it's reality, not perspectives, which makes what theories say true. Science discovers truth. Scientific theories describe reality, and reality is prior to, independent of, thought. Here's an argument, also in the text, chapter 4, for believing that scientific theories are approximately true descriptions of the world. This is the no miracles argument for scientific realism. It goes like this. If scientific theories were not, at least, approximate true descriptions of the world, then the success of science would be miraculous. And by that I mean an amazing coincidence, not some sort of divine intervention in the affairs of humans. But the success of science is not miraculous. Realism is the best explanation for the spectacular success of the technological innovations and powerful explanations science has produced. Therefore, scientific theories are approximately true descriptions of the world. I'll say this argument originates with Hilary Putnam. Again, realism is the idea that science aims to give us in its theories a literally true story of what the world is like, and accepting a theory involves believing that what it asserts is true of the world. Some examples. Scientific realists believe that the success of such theories as these is why they explain reality accurately. Newtonian mechanics and Newton's theory of gravitation explain the observed motions of the planets, eclipses, the sunrise, tides. From quantum mechanics, quantum mechanical descriptions of reality explain the behavior of subatomic particles. For example, radioactive decay, you might hear with a Geiger counter detector. Cosmic evolution explains the origins, changes, and the composition of energy, matter, and life. Radio telescopes detect cosmic microwave background radiation, the afterglow of the Big Bang. And finally, the synthetic theory of organic evolution explains the fossil record. We observe ancient life to modern life transformations of form and function. The theory of evolution explains complexity, diversity, and the distribution of life on Earth. It explains antibiotic, pesticide resistance. When a theory explains phenomena well and makes risky but accurate predictions, this indicates that the theory is approximately true. So here's an image comparing the skeletons of a gibbon, a human, a chimpanzee, a gorilla, and orangutan. How, if at all, are these animals related? Biologists use fossils, comparative anatomy, and DNA sequence data to describe ancestral relations, presumed ancestral connections. Family trees, such as this one, and here I'm giving you a branching tree diagram, which shows the inferred relations between orangutans, gorillas, humans, and chimps. Family trees such as this are theories about the actual historical relationships, according to scientific realists. Humans and chimps are more closely related to one another than either group is to gorillas. Well, why is that? Well, you can't draw a line around a natural grouping or clade of all of the apes that does not include humans. So humans are apes. It's as simple as that. So on the scientific realist view, family histories, such as the family history of apes, are theories about actual relationships. Look at the tree diagrams in the Wikipedia entry for ape. Here they are. Prior to 1960, we have a different tree diagram than we do in the 1990s and on. Looking more closely at this, we can see that humans were in a separate group. And the diagram represents the idea back in the 1960s we had, based primarily on comparative anatomy and fossil evidence. It represents the idea we had that chimps and gorillas and orangutans and gibbons were more closely related to each other, formed a natural grouping, than humans. Humans were off to the side. Subsequently, given DNA analysis, the family tree has changed dramatically. Take a close look at this. You'll see here that it shows Homo, that's humans, Pan, that's chimps, as themselves being in a natural grouping, a later derived group of animals evolving from a common ancestor, which is also shared with gorillas. And basically, by looking at this, you can see Hylobates, that's gibbons, Pongo, that's orangutans. You'll see that gorillas, humans, and chimps are then on this view, which this represents, more closely related than, say, gorillas, chimps, and humans are to orangutans, and again, orangutans themselves and gorillas and chimps and humans together form a more natural grouping, a more recent derived group than the gibbons. So family histories, they're represented as trees here, are actual theories about actual relationships. Let me develop further this difference between realists and anti-realists with respect to the history of life on Earth and biological species. The history of life in biology is looking at patterns, looking for patterns. The central ideas of evolution are that life has a history, it has changed over time, and that different species share common ancestors. In this diagram, you can see how evolutionary change and evolutionary relationships are represented by family trees, how these trees are constructed, and how this knowledge affects biological classification. You will also see a timeline of evolutionary history and information on some specific events in the history of life, human evolution and the origin of life. Now, these trees are hypotheses. If you read about or watched the video about the evolutionary history of whales in the 1970s or 80s, you might have seen a tree that looks something like the one on the left, which implies whales are closely related to an extinct group of mammals called mesonkids. Today, we know that the origin of whales is better represented by the tree on the right. Whales and water-loving hippos are closely related. Why the change? Because the discovery of new DNA evidence caused paleontologists to reevaluate their interpretations of fossil evidence, leading to a revision of our understanding of the evolutionary relationships in this group. So how do they do this? Characteristics are heritable traits that can be compared across organisms, such as physical characteristics, genetic sequences, and behavior. A shared character is one that two lineages have in common, and a derived character is one that evolved in the lineage leading up to a clade, and that sets members of that clade apart from other individuals. I'll say more about what clades are shortly. Biologists use shared derived characters to group organisms into clades. For example, amphibians, turtles, lizards, snakes, crocodiles, birds, and mammals have all had 4 limbs. You don't see obvious limbs in snakes, but fossils show that ancient snakes did have limbs, and some modern snakes, for example boas and pythons, actually do retain rudimentary limbs. 4 limbs is a shared derived character inherited from a common ancestor that sets apart this particular clade or group of vertebrates. The diagram shows where 4 limbs are thought to have evolved in the vertebrate clade. So what's a clade? This is a grouping that includes a common ancestor and all the descendants living and extinct of that ancestor. The root of the tree in each diagram represents an ancestral group, the group from which later groups evolved. And the tips of the branches represent the descendants of that group. As you move from the root to the tips, you move forward in time. Using a phylogeny or family tree, it is easy to tell if a group of lineages forms a clade. Imagine clipping a single branch off the phylogeny. All of the organisms on that pruned branch make up a clade. Are clades real or convenient fictions, useful only for classifying? Do they explain actual origins of species? Realists think so. This is how scientific realism in biology functions with respect to questions like, how do species originate? Cladogenesis, or the branching of a clade, happens when a group of organisms splits off from an ancestral form. New species form when a subpopulation becomes genetically isolated from their ancestors. It is a new species only if it cannot interbreed with its ancestral group. Cladistics classifies organisms based on shared derived characteristics, such as the amniotic egg, 4 limbs, or milk production in mammals. These trace back to a group's most recent common ancestor and are not present in more distant ancestors. So here are 3 basic realist assumptions in cladistics, the science of classifying organisms based on these shared derived characteristics. Change in characters, traits, occurs in lineages over time. Any group of organisms related by descent from a common ancestor form what is called a clade. And there's this branching pattern of cladogenesis, which is one form of biological evolution that produces new species. So for scientific realists, given the fossil record, DNA, and the comparative anatomy of modern even-toed mammals, whales probably descended from land-dwelling herbivores. Anti-realists don't deny this. It's the best explanation of data so far, but think we must remain uncommitted about the exact history or whether the total story is true, because stories change or even get rejected over time in light of new observations. Anti-realism is a kind of skepticism about the scope and duration of scientific knowledge. Tree of life diagrams constantly get redrawn. Scientific anti-realists notice that the history of science is filled with stories about how scholars and scientists abandon old but once useful theories in favor of better theories when new data emerges. All current theories, then, are suspect as well. So we can't count as evidence for the truth of a model or theory how useful any scientific method or theory is. The tree of life is a model that diagrams inferred relationships between biological species. I recommend you explore this. This is at www.evogenio.com. It's also in various languages. There's a link to this video in Canvas as well. Let's be more specific about anti-realism. It's basically the denial of what scientific realism accept? Your basic anti-realist thinks that scientific theories are not best understood as more or less accurate descriptions of real phenomena. Framing hypotheses and testing predictions via observation and experiment is not a reliable procedure for obtaining and improving knowledge, that is, justified true belief of phenomena. Scientific theories with predictive success actually explain only observable phenomena. The world, then, described by scientific theories is not largely independent of our thinking, language, and theorizing. Here's Bas van Fraassen. He's an anti-realist, and he rejects or is skeptical of scientific realism. This comes from his book, published in 1980, called The Scientific Image. To develop an empiricist account of science is to depict it as involving a search for truth only about the empirical world, about what is actual and observable. It must include throughout a resolute rejection of the demand for an explanation of the regularities in the observable course of nature by means of truths concerning a reality beyond what is actual and observable, as a demand which plays no role in the scientific enterprise. Van Fraassen thinks that what counts as an observable is an objective, theory-independent fact. X is observable if there are circumstances which are such that if X is present to us under those circumstances, then we observe it. For example, one only observes something when the observation is unaided. One doesn't see cells through a microscope. Instead, one sees an image which the scientific skeptic understands one way, but the scientific agnostic understands a different way. So this is constructive empiricism. It's the idea that some useful theories model reality but need not be true. Some useful theories model reality but need not be true. They must only be empirically adequate. Let's talk about this. A theory is empirically adequate when whatever it asserts about observable phenomena in a model of the real world is true of the model, but not necessarily of the actual world. Sometimes accurate descriptions are useful, even if they don't explain. We can call a person neurotic or conscientious without actually explaining this trait, and still it's useful to do so. The anti-realist rejects scientific realism because science makes mistakes. The now rejected phlogiston theory of combustion thought that flammable materials contained phlogiston, a substance without color, odor, taste, or mass that gets liberated when burning happens. The now rejected caloric theory of combustion said that heat is a fluid, called caloric, that flows from hotter to colder bodies. Perhaps you've heard of the ether theory of light, namely that light travels via waves through a medium called ether. So no ether, no caloric, no phlogiston was ever found. Yet these were used to explain heat. Modern thermodynamics describes heat as energy transfer via conduction and radiation work. Einstein's special theory of relativity implies that the speed of light or any electromagnetic wave is a universal constant, and that no medium within which light travels is necessary. So the history of science is full of theories that postulated the existence of things we now no longer believe exist because they provided no explanatory value, and for which we could find no evidence whatsoever. So here's anti-realists on those family histories I showed you, looking at the ape-human connections. Family histories are theories about possible relationships only. Here's an argument anti-realists have against scientific realism. It has a clunky, awful name, namely the pessimistic meta-induction argument. It goes like this. The history of science has numerous revisions and rejections of previously successful theories long since abandoned due to empirical inaccuracies and the theories being superseded by better models. See, for example, obsolete theories featuring now rejected explanatory entities such as phlogiston and caloric and ether. Now, if most theories produced by science get abandoned, then its current theories are suspect, and so cannot count as evidence for the truth of scientific practice and theorizing. Practices and theories which are not successful can't be approximately true, as scientific realists say. Therefore, probably scientific realism is false, or we should not accept that scientific theories are approximately true about unobservables. So for the anti-realist, science only aims to give us theories which are empirically adequate. Here is more detail now about the anti-realist position against that of the scientific realists. If prominent scientific theories are false, why would they be so successful? Well, here's what the non-realist says. The success of current scientific theories isn't a miracle. It's not even surprising to the scientific Darwinist mind. For any scientific theory is born into a life of fierce competition, a jungle red in tooth and claw. Only the successful theories survive. The ones which, in fact, latched onto actual regularities in nature. Here's the thing. The best available theory might not be true. Here's the point. A theory can be empirically adequate by describing observable regularities in nature without being correct. A theory can account for data, but be wrong in its interpretation. Competition between theories depends upon which theory accurately describes the observable world best. It does not depend upon which theory is correct. Thus, it would not be miraculous for science to arrive at an empirically adequate, scientifically successful, yet false theory. Thus, scientific realism is not supported by the success of science. Anti-realism, then, is the denial of realism. Theories refer to observable phenomena and unobservable phenomena, but we only have knowledge of the observable stuff. Accepting a theory only commits you to the claim that the theory produces some true claims about what we can observe. We are not committed to believing that whatever the theory says about unobservables is true, or even that what it says is false. We may remain agnostic, doubtful about the existence or the activity of alleged unobservables. And so in one sentence, this is what constructive empiricism is. Again, this emerges as a reaction to scientific realism. Constructive empiricism is an anti-realist position. On this view, science only aims to give us theories which are empirically adequate, or that save the phenomena, right? Capture, describe the phenomena. Empirically adequate. What's this? This is when what a theory says about observable things and events is true. An empirically adequate theory adequately accounts for data. That's all. Doesn't mean the theory is true. There is this difference then between accepting a claim and believing it. There's a difference between accepting a hypothesis or theory and believing it. I want to make that clear here. Can you think of examples? You can accept a theory but not believe it. Unlike belief, acceptance has a social dimension. It can be context dependent and provisional. One may decide deliberately, voluntarily to accept P. Belief implies accepting, but accepting does not imply belief. So think of it this way. Belief is a subset of accepting. For any theory, if you believe it, you accept it. But you can accept that it accounts for data. You can accept that it's empirically adequate without actually believing it's true. Of course, you can believe it and accept it. Here's Bas van Frossen's example of accepting but not believing. We want to know why the mouse runs from the cat. Here's a theory. The mouse thinks the cat is its enemy, intent on killing. So the mouse runs. What is postulated here is the adequacy of the mouse's thought about the nature of cats and mice. The cat hates him. So the reason the cat is chasing the mouse is that the cat hates the mouse. That explains the behavior of the cat, explains the fact that the mouse thinks the cat is its enemy. But is it true? I mean, we can accept that explanation. It accounts for what we observe. The Darwinists would say, no, don't ask why the mouse runs from its enemy. Species, mice, which did not cope with their natural enemies no longer exist because they didn't leave offspring. That's why there are mostly mice who do run. The cat doesn't need to hate the mouse. Though hatred is an acceptable, empirically adequate explanation, you don't need to believe it. There are other explanations. What I want to do here is, with another example, show the difference between accepting and believing. An American woman in Mississippi who was shot in the head by her husband not only survived, but made herself a cup of tea. Police and doctors hailed the survival of Tammy Sexton, 47, as miraculous after a bullet from a .38 caliber handgun struck her squarely in the forehead, passed through her skull, and exited through the back of her head. She is expected to make a full recovery, while her husband shot himself dead after the attack on his wife. Sheriff Byrd, there's no way she should be alive other than a miracle from God. You just don't hear of something like this. Somebody gets shot in the head and they're dead. The bullet passed through the lobes of the woman's brain without causing major damage. Dr. Patrick Pritchard, an assistant professor of surgery at the University of Alabama, Birmingham, said, "There is a space in the brain where a missile could pass without doing any major damage." Is it possible? Yes, it would be rare. In this case, one may be said to accept that a bullet can pass through a brain without doing major damage. But I don't believe it. I don't believe that a bullet can pass through a brain without doing major damage. So the sheriff, the rest of us can accept that, okay, yeah, sure, a bullet could pass through without doing major damage. And yet we don't really believe it. Okay, we accept that that would account for it. It's a rare possibility. But we don't believe that it actually happened. Nevertheless, the woman appears to be okay. Rare events, unlikely explanations, happen. Again, constructive empiricism is an alternative to scientific realism. To accept a theory means to think that it is empirically adequate. That's all. Doesn't mean you believe it. To believe a theory means to think that one of its models correctly represents the world. Thus, belief implies acceptance, but acceptance does not imply belief. So here's a summary of the anti-realist position. Accepting a theory as descriptive or explanatory does not entail that one believes literally that whatever it says is true. Scientists are empiricists. The only legitimate source of information about the world is experience. Without observables, there is no reason for acceptance or belief about the subjects of scientific inquiry. When scientists accept a theory, they believe that it is empirically adequate. Only what it says about observables is probably true. An empirically adequate theory has at least one model which correctly represents observable phenomena, appearances, but not necessarily reality. There's an odd result here for realists that an empirically adequate theory might explain and yet be false. All it has to do is be better than available rivals to be useful. The scientific explanation is at best sufficient or empirically adequate only if it answers the question, how possibly could the observed event one seeks to explain have come about, given specific circumstances and alternate outcomes? For the anti-realist, theories help us to predict behavior, observed behavior of the world. In order to do this, they need not be true, but they should be convenient conceptual schemes for summarizing, classifying, ordering, and predicting phenomena. For example, the behavior of solar systems postulate invisible forces and properties behind structure, motion, and location of stars and planets, extrasolar planets. Theories help us predict the behavior of particles. See the paths of particles emitted as a result of radioactive decay in a cloud chamber. When subatomic particles enter the chamber, they collide with air or alcohol vapor molecules, producing free ions. Vapor in the chamber condenses around these free ions, forming droplets. The droplets are what form the trail. Empirically, for the anti-realist, scientific theories help us explain the fossil record. Dinosaurs are invisible, extinct reptile ancestors of existing birds and crocodiles. Understanding these aspects of the world consists only in being able to predict how it behaves in various models. It involves no commitment to the actual existence of the things described that are supposed to be explaining what we observe. This is what scientific anti-realists think, that science constructs practical, pragmatic models which might, but need not map onto reality. It aims only for empirical adequacy. Theoretical terms and concepts are artifacts made up by humans. They refer to models, not necessarily to reality. Thus, anti-realism is denial of realism. See Wikipedia entries for these scientific model examples. I'll describe a few here. This is the Big Bang model of cosmological evolution. The article in Wikipedia on the Big Bang is excellent. You should have a look at that. There's also multiverse theory, which is a new cosmological model of the universe. It's the idea that our universe, like a bubble, exists among countless other parallel universes, each having various physical constants and different laws of physics. Now, if a multiverse exists, then finding ourselves in one where life is possible is not improbable and needs no special explanation. Order and complexity, then, is bound to emerge under extremely varied circumstances in many worlds. Ours is not special and not unique. Here's the liberal versus conservative model of morality, in this case described by psychologist Jonathan Haidt. There's a short video linked to this in Canvas. You should have a look at it. It's very interesting. He postulates that basically liberals have 2 morality channels while conservatives have 5, and there are these differences. Liberal versus conservative moral foundations. This graph of responses to 15 questions describes which considerations are relevant to deciding whether something is right or wrong. Those who describe themselves as very liberal gave the highest relevance ratings to questions related to the harm, care, and fairness, reciprocity foundations, and gave the lowest ratings to questions about the in-group loyalty, authority, respect, and purity, sanctity foundations. Here's a diagram of the 5-factor model of personality. The idea here is that you can describe a person's personality along 5 continua. These are called the Big 5 personality traits. The Big 5 factors and their constituent traits are these: openness, conscientiousness, extroversion, agreeableness, neuroticism. For each of us, all of us, we can be described along these 5 continua spectrums. Applying the Big 5 factors here to a person with whom most of us are familiar, namely Oprah Winfrey, we can see its usefulness. So on the openness factor, she is more inventive, curious than cautious and conservative. On the conscientiousness factor, she is efficient and organized, hence her great fortune, as opposed to being easygoing and careless. She counts as an extrovert. She is outgoing, energetic, not shy, withdrawn. With respect to agreeableness, she's friendly, compassionate, not so much competitive and outspoken, although she is somewhat those things. Again, it's not that we lie to an extreme on these spectrums. All of us are somewhere between, but some of us are more agreeable and neurotic and extroverted than others. Neurotic. Oprah Winfrey, of course, is probably not best described as neurotic. Neuroticism. Oprah Winfrey is probably described by no one as sensitive and nervous, neurotic. She is more secure and confident in her character. Okay, surely factors describe her accurately, but do they explain her beliefs and her actions? A theory or model isn't very good if it only describes, but this is what anti-realism offers. Descriptions, not so much explanations. Acceptable theories, adequate theories, not necessarily true ones. There are problems with the 5-factor model of personality. As with most models, this one is limited in scope and descriptive or predictive rather than explanatory. Statistically speaking, extroverted people fare poorly under pandemic quarantine. That's a useful understanding. But this doesn't explain why they are extroverted, why they are so stressed. Also, the 5 factors are vague, changeable, and difficult to measure. And the 5-factor model analysis downplays other relevant personality traits. As a theory, it is non-disconfirmable. How good is a theoretical model if it only describes, but does not explain what is actually going on with someone's behavior? For instance, calling someone ADHD or describing someone as hyperactive fails to tell us what causes such behavior. Anti-realists are okay with practical models like this, while realists aim for literally true models of reality. Next, I discuss that last part of Okasha Chapter 4 on underdetermination in the next lecture for Module 5, in addition to Chapter 5 in Okasha and Handout 5 on what limits science. So read Chapter 5 in the Okasha text and read Handout 5. This is the end of the slideshow.